You're listening to Everything Environment by Mongabay India. This is Wild Frequencies, a 3-part mini-series.
Hello and welcome back to episode 2 of Wild Frequencies. I'm Kartik Chandramouli.
I'm Shreya Dasgupta, and this is the podcast where wildlife researchers from India share their stories of sounds from the animal world. And they decode those wild frequencies for us, one song, one howl, and one chirp at a time.
So in the last episode, we learned 2 very interesting things. One, that scientists can identify a whole lot of species just by listening to their calls. And 2, that these calls can also sometimes be used to count those very animals. Both are very important fundamental things. But we have something quite different today.
Yes, today we'll talk about the one thing that fascinates me a lot, which is animal behavior. In fact, I think that's been my favorite part of being on this planet. Just being able to watch other fellow beings and see what they do. Even just observing my cat and dog, or watching those birds and monkeys outside as they eat, relax, get those zoomies, and even when they get upset. And what I've realized is that if you spend even a few minutes watching animals every day, you begin to see them as individuals with so much personality. They are not just a quote-unquote member of a species.
They are individuals, constantly making decisions on how to navigate this complicated and challenging world. Which is why many researchers say that if you want to protect a wildlife species, you also need to understand them more deeply. Understand their behaviors, understand how they live their lives. Like, what do they eat? Where do they go to eat? How do they find their friends and partners? How do they avoid predators? And how do they avoid people?
One way to make sense of animal behavior is by watching animals, of course. But researchers are finding out that you can also learn a lot if you listen to them. Because as animals go about their days, they communicate in various ways. Often that communication is vocal or through sounds of some sort. And that is what we will hear in this episode. How researchers are beginning to figure out animal behavior by listening to what sounds they produce.
In March this year, we flew to Guwahati in Assam. We had some interviews lined up near Kaziranga National Park. But before we did those, we had a day to ourselves. So we thought, why not just be tourists for a change and see wildlife from a jeep safari?
And we saw so much. So many birds, rhinos, and hog deer. And after a while, we got incredibly lucky. It was about 8 a.m. or so, lightly drizzling, the sky completely overcast. We were watching a rhino wade through water, chomping on water hyacinth. And then our safari guide got a call. After he kept his phone down, he turned around and said, "There are elephants ahead."
We rushed to the spot. There was tall elephant grass on either side of the jeep track, so we had to watch carefully for any movement. And that is when we saw her. A female elephant close to the track, pulling out clumps of grass with her trunk. After a few minutes, she gave this low-pitched call and crossed the road. There were many more in the herd, but the grass was so tall that we could barely see them, although we could hear them quite well. We could hear them move through the grass and we could hear them eating. And just as we were about to leave, we heard some elephants behind the grass, producing these very loud calls.
Of course, we didn't know what these calls meant, so we asked someone who is more tuned into elephant sounds than us.
I'm Seema Lokhandwala, and I'm currently a researcher with the Elephant Acoustics Project.
Seema is also the founder of the Elephant Acoustics Project, which is trying to understand how Asian elephants communicate. We interviewed her after our safari at a hotel.
So when I started doing my preliminary research or started reading about elephants, I realized that acoustics is one thing that has not been studied in Asian elephants. Back then, there was only one paper that was published on Asian elephant acoustics. And there was this insane amount of research that's already been done on wild African elephants by Joyce Poole and Cynthia Moss and a lot of other people, like even Katie Payne. So a lot of people had done this for African elephants, but there was this huge gap for the Asian elephants.
The researchers Seema mentions, Joyce Poole, Cynthia Moss, and Katie Payne, they have been studying how African elephants communicate for decades. One thing they've looked at very closely are all these different sounds that African elephants produce. And they've recorded a whole range of sounds, from trumpets and rumbles to snorts, roars, and cries. All these calls you just heard are African savannah elephant calls from a database called the Elephant Ethogram. It was developed by Joyce Poole, and it's a massive collection of different elephant behaviors that she and others have visually observed in the field. For each of those situations, they have noted how the elephants were communicating, including vocally. Basically, what was the context in which the elephants made those sounds? Were they happy? Were they playing? Were they worried? Or angry?
When Seema was starting her elephant research, this kind of detailed long-term acoustics work did not exist for Asian elephants. So, she wanted to help fill this gap. And to do that, she picked Kaziranga National Park.
Kaziranga is a very important place for elephants. In fact, Kaziranga and its surrounding landscape supports the second highest Asian elephant population in all of Asia, after southern India. So, it's also very important from a conservation point of view.
It's in this context that Seema started studying the behavior of Asian elephants through their sounds, some 8 years back. Her days in the field looked something like this.
Mostly, you wake up around 6 o'clock, 7 o'clock, and then you get yourself ready with all the acoustic equipment that you have to check, all the recorders, everything, all your extra batteries, or your power banks. You pack them in, you go to the field with a guide and a forest guard.
Together, they would decide where to start the day's journey and what elephants to follow. Sometimes, they would follow semi-captive elephants, individuals that the forest department uses for patrolling. These elephants, Seema says, are allowed to roam freely in the park for a large part of the day and are not tied to one place.
Or Seema could end up following a herd of completely wild elephants. Whatever the case, once she had elephants in sight, she would hit record on her mics. And then she would try to follow them in her jeep for as long as it was possible.
As soon as we see the elephant in the vicinity, we switch on the record because we don't know when the call is going to happen. So we have to always keep the recorder on. And that's one of the reasons that the recorder requires insane amount of battery.
With the recorders on, Seema would carefully observe all the visible individuals and make a note of all that they are doing. For example, are the elephants greeting each other? Are they eating? Are they playing? Or are they agitated? And if an elephant calls while doing any of this, Seema would quickly record the observation.
We speak in the mic that the next individual had made this multiple calls and this is the context in which these calls have been made. Also the time duration, what is the time of the day and all of those small details, what's the distance of the recording. Even with that ex individual, if there are other multiple individuals in the herd or any of those kind of background information which is also required is also noted down.
These notes are very important because acoustics researchers like Seema often end up with hours and hours of audio footage every day. Most of this is background sounds like planes passing overhead, vehicles driving past, sounds of their own jeep, calls of birds, and as Seema puts it, a lot of people talking.
But the notes can help her identify clips that are actual elephant calls. This way, over the last several years, Seema has been building a picture of the various kinds of calls that Asian elephants make and the behaviors they are generally associated with.
Trumpet, rumbles, chirp, and roars.
That's trumpets, rumbles, chirps, and roars. are the four, you could say, building blocks of Asian elephant vocalizations that researchers have observed in Asian elephants. Let's start with trumpets.
Trumpets is the most common call, and everybody, as soon as they hear the word elephant, they will hear this kind of sound that goes like, that's the sound that is the trumpet. Very difficult to mimic.
The elephants Seema has observed in Kaziranga tend to mostly trumpet in two situations. One is when they are playing with each other.
When young, very young, like let's say about 5 to 6 years, elephants, they keep playing with one another. And when they chase one another, they have these play trumpets. They're these fluffy trunks that go around and have these play trumpets that go. So you see that a lot while they are playing with one another, these young adults.
Seema has also seen elephants trumpet when they are distressed for some reason. For example, she's observed a female elephant trumpet upon seeing people and run into the forest. She's also seen captive elephants trumpet when they are unhappy with their mahout or handler.
Also, the mahout and the elephant equation is of a dominance equation. The mahout is a dominant party and the elephant is a submissive party. And when they interact, mahout wants the elephant to do something and the elephant doesn't want to follow the command. It does this huge trumpet call.
One disclaimer, the behaviors and calls that we are mentioning are what Seema has personally observed in Kaziranga. They're more like a snapshot. As she says, it's possible that these large intelligent mammals produce certain calls in situations that she hasn't seen at all. Anyway, back to trumpets. Seema has seen that elephants in Kaziranga usually trumpet either when they are playing or when they are distressed or angry.
It's not like a contact call. Like an elephant wouldn't trumpet to another elephant that, oh, I'm here, kind of a thing. That's not where most of the times trumpet are used.
To contact each other, the elephants produce a different kind of call. A rumble.
Like let's say an X individual hasn't met the Y individual for a long period of time, they will greet each other and these greeting calls are rumbles.
So, if we had to anthropomorphize, rumbles are a way to say hello. Rumbles can also be a way for elephant herds to stay together.
Rumbles are mostly the calls that are either contact calls or let's go rumbles. Like a female, adult female who want to have a herd move in X direction. So she would stand in the direction of the movement that she wants to make it. She'll stand with one right leg up or a left leg up depending on the way she wants to move it forward and would make this low frequency call that this is the way I want to go. And then if everybody else agrees, if all the other females agree, then they'll go start moving in that direction.
That female elephant we mentioned in the intro, who produced a low-pitch sound and crossed the road, turns out that call was a rumble. Although, what was she trying to say? We don't really know.
In 2009, some researchers published a study about vocalizations in Asian elephants in Mudumalai Wildlife Sanctuary in Tamil Nadu. Even there, they saw that elephants would rumble to greet each other and matriarchs would rumble as a way to convey, let's go. But they also saw some elephants rumble when they were disturbed by humans or vehicles. Sometimes several individuals would rumble together when they encountered other species like bears or wild dogs.
Unlike trumpets though, which are high-pitched, rumbles are low-frequency calls. In fact, they can often be below 20 Hz. Typical human hearing range starts from 20 Hz. So you may hear these calls like we did during our safari. And these audible rumbles can sound like a motorbike starting, as Seema likes to say. Although I thought it was like one of those sounds from Jurassic Park. But often, elephant rumbles can be inaudible to us.
While we may not be able to hear them, elephants can. In fact, research shows that their rumbles travel not just through air, but also through the ground. And elephants even several kilometers away can detect these seismic signals. Whether the elephants can figure out what these rumbles mean and then communicate back, that we don't know.
Then, there's a third kind of call that Asian elephants make. These are the roars.
And the roars are like a loud cry kind of things that, oh, like that sound that produce. And it's mostly produced by young ones that when they are disturbed.
For example, Seema once saw a young elephant being pushed away by an adult female. And this is what she recorded. If you are an elephant, disturbance can come in other forms too.
I have seen roar when a young adult was chased by a rhino. So that's a very common situation when they have interactions with other species also, you see.
Or, as researchers observed in Mudumalai, young elephants sometimes roar while playing.
Which brings us to the fourth type of call. Back in a jeep in Kaziranga, I was grinning as we were about to leave the park. I had seen rhinos and a tiger in the wild for the first time. But just as we were heading back, we saw a couple of jeeps waiting on the forest track. We also paused, and then we heard something. At first, I thought it was a bird. But then we realized that it was a young elephant who was making this strange bird-like sound as the tourist vehicles went by. Seema told us later that this is called a chirp. And honestly, the name quite suits it.
This is not a very frequent call, and not all the elephants produce these calls also. So certain individuals are only what we observe producing these calls. Some of them have also used this call to greet individuals. We observe them while they're disturbed by humans also, disturbed by a vehicle, and the elephants used to chirp. So we don't know actually what the major context of these calls is.
In the 2009 Mudumalai study as well, the researchers saw elephants chirp when the individuals were quote-unquote confused or alarmed. For example, they sometimes chirped when they smelled the presence of other species, or they sometimes chirped on seeing vehicles. Seema in fact told us another interesting thing about chirps, that chirps have only been observed in Asian elephants. African elephants don't seem to produce this call. Although there was one study from 2005 by Joyce Poole, the African elephant researcher, she saw that a 23-year-old male African elephant in a Switzerland zoo, he had learned to chirp by imitating two Asian elephants. That seems to be the only known case of an African elephant chirping. But you could say that in general, Asian elephants chirp, but African ones don't. And we don't know why this is the case.
So to recap, Seema told us about the 4 building blocks of Asian elephant calls: trumpet, rumble, chirp, and roar. But it's not like elephants only make just one call at a time. They also often combine the calls. So an individual may chirp and trumpet, trumpet and rumble, or roar and rumble.
At the moment, we've barely begun to understand Asian elephant vocalizations and the behaviors they convey. But if we did build a more complete picture, maybe some years down the line, we could perhaps begin to understand these incredible mammals a little bit better.
We could, in theory, maybe even use that understanding to manage human-elephant conflict, a very serious problem in India. Take Kaziranga for example. Kaziranga is a living, breathing, dynamic place.
Have you guys had breakfast? Yeah. Would you like some tea?
I think Kaziranga National Park is probably one of the most important protected areas in the entire country. I am Varun Goswami. I am a senior scientist and director at Conservation Initiatives, a Northeast India-based organization.
Varun has studied Asian elephants for a long time, both in southern India and in and around Kaziranga.
Kaziranga National Park, it's an extremely productive floodplain ecosystem. It's on the southern banks of the Brahmaputra River. So all along its northern boundary is the Brahmaputra River. And the river floods pretty much on an annual basis. And when it does, it recharges the park. And so it's able to kind of support the amazing productivity of vegetation. And because of which it has among the highest densities of a whole assemblage of different herbivore species, elephants being one of them. And in turn, these herbivores also support one of the highest densities of tigers anywhere in the park.
But Brahmaputra flooding is not a joke. When it floods, as much as 90% of the park can get inundated.
During that time, animals need to move out of the park and look for refuge elsewhere. So that's their adaptation to this dynamic ecosystem.
And what's outside the park? Lots of villages, tea estates, shops, and hotels. That's in fact the story of most protected areas in India. Elephants have to navigate increasingly fragmented landscapes. And as they move through this challenging world, they need to communicate with each other.
So they have an amazing repertoire of different kinds of vocalizations that they engage with. All of them have different meaning. We are still trying to understand a lot of that. And then there's this whole other part of their vocalization that's not even audible to us. One elephant can be talking to another elephant 5 kilometers away saying, hey, over here there's a slightly risky environment because people are doing this, so maybe you shouldn't come this way or whatever, I don't know. But the fact that they have the potential ability to have all of these conversations in the immediate vicinity of each other, like through sounds that we can hear and try and understand, as well as those that we can't hear and can't see either because there might be two individuals that are very far away from each other. I think all of this is going to be very important in terms of just elephants navigating a space which is both fragmented and potentially risky for them.
If we could potentially listen to these elephant conversations and understand them, perhaps there will be a day when we have recorders all around places like Kaziranga listening to elephant calls and telling us how elephants are going to behave in an area. We are not there yet, but hopefully we will be in the future.
That wraps up our Kaziranga journey and our first segment. If you listened to our first episode, there was a quiz at the end where we played 2 calls. The first call was this. Some of you may have guessed it already. This is an elephant chirp. For the next answer, you'll have to wait till the next section.
From elephants, we now move to an animal that's so small that an elephant would probably find it very hard to spot. And we'll hear from a researcher who listens to this tiny creature to understand how it lives its life. A tiny animal that has a deafeningly loud sound.
So I am interested in understanding how animals interact with each other and their environment, and towards this end I have been studying the behavior of insects and birds for a while now, and I have been doing this using sound as a tool.
This is Manjari Jain, an associate professor at IISER Mohali. Initially, Manjari wanted to study birds using acoustics, but for her PhD, she picked, crickets. So why crickets?
My PhD supervisor worked on insects, and of course when I joined I wanted to work on bird acoustics, and I was like, this is what I want to do. I want to work on birds and I want to understand what they are talking about. And Rohini was like, oh no, not this lab.
That would be Rohini Balakrishnan, a scientist at the Indian Institute of Science in Bengaluru. Rohini even has 2 species of crickets named after her.
We work on insects, Manjari, and this is what we do. Then I realized that that was the only lab, in fact, in India that was studying acoustics.
So, crickets. These insects can be extremely loud. Some cricket chirps can even reach up to 100 decibels, which is as loud as your car horn, a rock concert, or a hammer pounding on a nail. To us, cricket chirps can seem like unnecessary noise. But for crickets themselves, sound is critical for survival. Because it is through sound that a male cricket tries to attract a female. Not flashy dances, not elaborate displays of color, but sound.
So the males produce these sounds, very loud, conspicuous sounds, which we can hear. to attract females, and they do so by rubbing their wings together. So they raise their forewings and they rub the wings. It's like a row of teeth under one of the wings, which is being scraped against the hardened edge of the other wing, like more or less like playing the guitar. And then parts of the wing then amplify certain frequencies and you have the sound.
But attracting a mate is not the only time a cricket produces sounds. The male also has a softer sound when the female comes close to him. It's called a courtship call.
When the female comes close to the male, they switch from this loud public announcement that I'm here to a more softer serenade, if you like, when the female is nearby. And in some crickets, we know that after they have successfully mated with the females, they also switch to what is known as a post-copulatory call. So this is a call after mating. The function of this is not very clear, but it could be to mate guard.
So that's a lot of calls focused around mating. A loud call to attract a female, a soft call to serenade a female, and a call to announce success.
They also produce sound in a completely different context, which is when they are interacting with other rival males of the same species. So these are aggressive calls. But after they fight and there is a clear winner that emerges, the winner produces this, loud victory call.
To me, crickets only sound like crickets. I had no idea crickets make all these different calls in different situations. Although, of course, it makes complete sense that they would. And we know all of this because, like Seema, researchers have also matched cricket calls to their behavior. But for this episode, we will focus on their mating calls because that's the basis of their existence.
Manjari studied these mating chirps in Kudremukh National Park in Karnataka. The park is a stunning expanse of wet evergreen forests and shola grasslands in the Western Ghats. It's beautiful to look at during the day. But imagine that you walk into it at night. What would you hear? We didn't know the answer, so we asked Manjari to tell us what she heard when she first visited Kudremukh at night.
When I walked into the rainforest, for me it was a complete cacophony. There was a lot of sound, there was a lot of crickets calling from all over the place. There were some calling from the ground, there were some calling from the understory, some from the canopy, some near, some far. And all these sounds were different. There are many individuals of the same kind, so on and so forth. So it was like a cocktail of sounds, if you like.
And all of this made her wonder.
That how do the females deal with this cocktail of sounds and how do they find the males in this complete mess?
Now remember, it's only the male cricket that calls to attract a female. The female only has to sit and judge and pick the best singer from the lot. But this is not a trivial matter. From all the cricket cacophony, the female has to pick a male of its own species. Only then can she ensure survival of her species. But when you have so many males of multiple cricket species chirping loudly in a forest, how does a female know who to listen to?
To find out, Manjari and her team had to do a series of very difficult, very tricky measurements in Kudremukh. Thankfully, a senior from her lab, Swati Divakar, had earlier surveyed the cricket community of Kudremukh and created a library of calls of the different cricket species there. If you remember the bat call library from episode 1, this is something similar.
So she had already found and characterized the call, so I already knew what I should be looking for, or rather hearing for. So come evening, 6 o'clock, we will put on our lead socks and our drill and march shoes, like literally military shoes, because Kudremukh also has a lot of snakes. And with our torches go into the forest.
Manjari would listen for the crickets, record their calls, and try to locate the males. And how do you find a cricket that's tiny and camouflaged within the leaves of a rainforest? The trick, Manjari says, is to look for its antennae in the foliage.
Crickets have very long antennae, much longer than their bodies. So if you can see two thin hair-like things moving in the air, that must be the cricket. Then you take the ladder, you climb on top of the ladder, you find where the cricket is, you put a flag under that tree. So this whole saga would get over by midnight.
The next morning, the team would go back into the forest and locate all the flags. Each flag was a proxy for where a male cricket sat the previous night and called. They would take a bunch of measurements, such as the height from which the males were calling and how far apart they were from each other.
I tried to understand how far does the sound transmit. If the male is calling from this position, how far is it going to transmit? With respect to how quickly it may degrade in different microhabitats.
Manjari also looked at various acoustic features of the cricket chirps. For example, how loud is the male of species A versus the male of species B? What frequencies are they calling at? What's the tempo of their call?
What is what we call as a temporal feature of the call, or how the energy of the call is distributed across time? So it's like trr, 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 or is it like pick, 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 pick? You see, the tempos may be different.
When Manjari analyzed all her data, she found that this is noise only for human ears. On the other hand, a female cricket is quite capable of ignoring everyone and only tuning into the calls of males of her species. So, how does this happen? Initially, Manjari had suspected that the male crickets position themselves far away from each other so that they don't drown each other out.
What we found that was not the case. They are not spacing out to avoid their noisy neighbors. The spacing is not doing it for them. Maybe there's limited space. They have to gather together.
Instead, a female is able to detect a call because of the combined acoustic properties of the call itself. For example, the ears of a female cricket might be able to pick up certain frequencies while tuning out others. But there still might be several species that call in similar frequency ranges.
In fact, most of the cricket calls, field cricket calls, this is a category of crickets, lie between 3 to 7 kilohertz. So any recording from the forest you get, it is going to be completely smeared between 3 to 7 kilohertz in the tropics, of course, because there are just so many who are calling in this frequency band.
Even when you have so many cricket frequencies overlapping, the females don't seem to get confused. As we said earlier, there are other attributes of the call that make it unique, like its loudness, tempo, or when it calls.
So the work in Kudramukh was interesting not because everyone is calling in their own frequencies, but even those who were calling in similar frequencies managed to get by based on, the other axis of segregation, because one is softer, the other one is louder.
This reminds me of how when I sit in a noisy cafe, I'm still able to listen to my friends. As for the crickets, Manjari says that a female's ability to selectively listen to males of only her species, that's an evolutionary feature.
This is hardwired. This is how they are born.
Okay, so female crickets are very good at identifying males of their own species. And it seems to be a feature of the calls or chirps themselves. But then comes the next obvious question. How does a female cricket choose when several males of her own species are trying to woo her with a slightly different chirp?
Much of biology is about variation. So there's variation not only across species, but there's variation within the species. So you have different males of the same species. But for the female, does it matter? Does it matter that one male is going like kruk, 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 other one is going like kruk, kruk, kruk? It's the same howl, but one is going at a higher tempo than the other. One may be a slightly louder than the other one.
Spoiler, it matters. It turns out that female crickets do have a preference.
Yes, we have found that there are general patterns. It is likely that the females are going to select louder males than softer males, obvious. The females are also likely to go for males that have longer chirps, so which means there is more energy in the call, which is likely to be a proxy for a better quality male. A female is also likely to go for a cricket which calls faster, so it has a higher tempo. All of these are proxies for higher energy levels. Okay, so yes, there is inter-individual variation in male calls, and yes, the females judge the males based on this. It matters, and we can say this definitely for the species of crickets that we have been working on.
So do you think introverts in the cricket world don't stand a chance?
No, they don't. but it's not as though they don't have other strategies.
For instance, Manjari told us about these field crickets on the islands of Hawaii. When the males call, it's not just the female crickets that are listening to them. Predators and parasites also eavesdrop. There's a parasitic fly in particular that listens for the loudest males. And when it finds one, it lays its eggs on the cricket. The fly larvae then burrow inside the cricket, eat it, and ultimately kill it.
Now, this is a huge selective pressure or a cost for a male that is calling. So then what should it do? Should it not call? If it does not call, then it's not going to reproduce. But if it calls, it stands the risk of not surviving. So it's like natural selection against sexual selection. Now, how do you trade off?
The males have evolved a few tricks up their wings. Some males don't sing at all. Rather, they hang around other loudly chirping males, Manjari says. When a female approaches the louder male, the silent one intercepts her. These silent kidnappers are called satellite males.
That is one strategy. The other strategy is to have alternate sensory modalities. So you can have surface vibrations, which you can send out, which will allow you to be silent. So you're not heard by the parasite and the predator, but the female will still find where you are. So the introverts will find a way.
Researchers like Manjari like to study animal sounds from an evolutionary point of view. For example, in a rainforest, why have certain sounds evolved the way they have? How do different sounds interact with each other? How do they reach the intended ears? And have animals found a way to avoid being heard?
Answers to these questions are particularly important for insects, a group we largely ignore.
We are mostly, worried about where have all the sparrows gone or where has the tiger gone? Why have the elephants declined? But think of it for insects. So many insects have disappeared from ecosystems all over the globe, and we are not talking about it. Where are the insects? When did you last see a firefly? I'm asking you, each one of you. When did you see a bunch of insects sitting on your window pane? It was not too long ago, but now we don't see them, right?
Insect populations are declining, and it's hard to see them around. But acoustics tools, supported by call libraries, like the cricket one that Manjari used, make it possible to listen for insects and find out if they're still out there.
Research like Manjari's also tells us how sounds interact in a forest, what individuals have to do in order to be heard, and what interferes with their sound signals. This is very useful as we become an increasingly noisy world. Human sounds drown out even the remotest parts of our planet. So bioacoustics can be a tool to figure out if and how our noisy lifestyles are affecting how insects communicate with each other.
This actually reminds me of what Seema said. Sounds can help complete the picture.
Like it helps you complete the story. Yeah. I found that very beautiful.
From a massive elephant to a tiny cricket. I love the journey that sound has taken us on. Maybe we should do a recap.
Yes, please.
We heard about how researchers in India use bioacoustics to understand animal behavior. Seema Lokhandwala listens to elephant calls in Kaziranga and dreams of building a library of elephant vocalizations matched to their behaviors.
We also heard from Manjari Jain, who at one point in her career would go into a rainforest in utter darkness to listen to male crickets, all to find out how dating works in their world. In fact, the second call from our quiz. This is the chirp of Landreva, a cricket found in Kudremukh. But if your answer was just cricket, that's fine too.
Bioacoustics is helping us figure out basic animal behavior. But that's not all. We humans are constantly changing our environments, and animals have to respond and adapt. Can we listen to these responses and adaptations too? Answers in the next episode. That's it, right?
No, wait. We still have to announce the quiz winner. Sanjita Sharma Pokhrel got both the calls right from episode 1. Congratulations! You win the title of the best listener.
This episode, we have 2 more calls for you to guess. Once again, send your answers to kartik@mongabay.com. Got it? I'll repeat. That's KARTIK@mongabay.com. Okay, now listen. Call 1. And this is call 2.
That's all we have for this episode. See you again very soon.
This podcast is presented by Mongabay India. This episode was reported and written by Shreya Dasgupta, who's a Newswire editor at Mongabay, and Kartik Chandramouli, Mongabay India's senior digital editor. I'm Abhijit Shylanath. I did the sound design, mixing and editing, and original music for the series. Our guests were Seema Lokhandwala, Varun Goswami, and Manjari Jain. Thanks to Elephant Acoustics Project for providing us with clips of Asian elephant calls, and to Manjari Jain for sharing recordings of crickets. Thanks also to elephantvoices.org for letting us use their recordings of African savannah elephants. Episode artwork by Hitesh Sonar. There are detailed show notes with links to all the studies we have referred to. You'll find a transcript there as well and names of everyone who helped us make this episode. Thank you for listening.